Hey guys, it's great to join this great session. So my name is Wei. I'm from the TensorFlow Developer Relations team. Today I'm really excited to show you how to use our TensorFlow Lite tool to build a machine learning based Android app. So if you can see my screen, let me make it larger. Basically, if you can do a quick search in Google using the keywords flower recognition Android Collab, the first result is what we are going to use today. This is a pre-prepared Collab. We are going to walk through the majority of all the steps here. At the end of the Collab, you will have a working Android demo that can recognize 5 different categories of flowers. Basically, let's get started then. So as Ken mentioned, in order to do machine learning models, there are basically two steps. One is first is to train a machine learning model on the server side, and then second is to integrate the model into your app. So instead of let's jump into step number 3 first, because we are going to need to download a large repository. It's going to take a little while, so let's just do this first. Hopefully you already have your tools Git set up. So I'm opening up my terminal here. I'm going to clone the TensorFlow example repository onto my computer. The repository is relatively large, so depending on your network, it may take a little while. So if you don't have your Git set up, you can just paste this into your browser, and then you can download the entire repository through your browser by going to this download zip button. So while that is going, let's go back to step number 2. As Ken mentioned, first you need to do a training to train the model to recognize different kinds of flowers. We have 2 different collabs, which is hosted notebooks. Remember to choose the one highlighted in the green area. This is a simpler path. It basically uses the newly launched TensorFlow Lite Model Maker tool to train an image recognition model. So for those who are not very familiar with Python world, basically this is a integrated and hosted development environment. It allows you to run Python code on Google's infrastructure, and you don't even have to pay for it. Basically, what you do is you upload some flower images to our server, and then we will use the model maker tool to train the model automatically for you, and then you can directly download the model and the label files, which we will use later in our Android app. That's the overall workflow. So let's walk through the Collab. Basically, the first step is to install the model maker tool. If you have not used the Jupyter Notebook, the thing to execute this code, you just click this little play button, and it may ask you to verify you are a human being or something like that. So in this case, it's pretty safe, so you can click run away. It's going to install a bunch of libraries. It may take a while, but generally it's pretty straightforward. You should not be getting any error or anything like that. And then the second thing is, actually, let me make this bigger. I think some people said it's too small. Okay, hopefully this is large enough. So once we installed all those dependent libraries, we can start importing relevant libraries. I think this should be pretty familiar to most of you.
Hey, Wei. Sorry to interrupt. Can you zoom in a little bit? I think folks are suggesting to have the fonts a bit bigger.
Right. Okay.
Thank you so much. Sorry for interruption.
Is this big enough?
Yeah, I think this should be okay.
Okay, cool. So now we can execute this second part of the code. It does not return anything, so you don't see any output at the bottom of the block, but basically it just imports a bunch of dependencies. The next thing you do is we need to download some flower image files, and TensorFlow has built-in functions for you to do that. Again, we just click the play button to do that. It will grab a file which has a bunch of different flower recognitions in 5 different folders, as you can see in this image. If you're interested, you can open up the file by yourself later. The download, actually, let me click this. Yeah, so once you have that file downloaded, I'm probably jumping ahead a little bit because that file is already cached in my notebook instance. But in your case, it's probably going to take a little while. Once you have that downloaded, you can execute the actual training code, which will use a data loader to load the file we just downloaded. And then the other thing it will do is just to split the data file into 2 different categories. One is called training set, and the other one is called the test set. So these are the fundamental machine learning concepts we don't have time to cover in this session, but in the future, we will cover those. So in this case, just directly execute this cell. It will give you some information back. It tells you how it splits up the files. And then the next thing you do is you actually build a image classifier based on the training data. So we execute this code block. It will create a classifier, and then you can see the output here. Basically, this is the model, the machine learning model that we built automatically for you. Underneath it, under the hood, it uses TensorFlow Hub to do all the heavy lifting. And then now we can see it's actually starting to train the model. We're going to run 5 iterations of all the image files. In this case, epoch basically means iteration. It's going to take maybe a minute or 2. And then you can actually see the accuracy as it goes. Then, as you can see, we give you the time, 17 seconds, and then there are a couple of iterations to go. A couple of epochs, sorry. So once that part is done, we can go into the evaluation part of the machine learning process. Evaluation is what happens after training. So as I mentioned, we split the data into training set and test set. After we do the training, we want to evaluate the data on the test set, which is what this particular code block does. So as you can see, at the end of the evaluation, we get a 89.992% accuracy, which is pretty good because we only trained it for less than 2 minutes. So it's I think it's reasonably good result. At the end, if we're satisfied with the model, we can just export the label files and the actual machine learning model. So once this code block finishes, what you can do is you click this little file icon on the left, and then you will be able to see 3 different files. You can ignore the sample data file, the sample data folder, but the other 2 files, you should download them, labels.txt, and then the other one, model.tflite. Those 2 files are the things that we're going to use in our Android app. Okay, so this basically wraps up the training step. for our machine learning model. I already downloaded the files, so I'm not going to do that again. But in your case, you should go ahead and download both files, and we will use them later. So now we are basically finished with step number 2. Step number 3, we just did at the beginning. We cloned the repository for TensorFlow examples. So hopefully, in your case, it's also finished on your side. Now let's move on to step number 4. Let me make this bigger. Yeah, step number 4 is basically after we downloaded the we cloned the repository, we can now open up the starter project. So we don't expect you to start from the scratch to build an Android app, because that would take too much time. Instead, what we are doing is we build a starter template for you to use. So what you do is you go to examples folder, and then Lite, and then code labs, flower classification, Android, start. So in the Android folder, there are two separate folders. One is start, and the other one is finish. Start is the one we're going to use, and finish is really the final project that you can use as a reference if you get stuck at any step. So let me open up my Android Studio here. Let me move this out of the way. If you are a Android developer, you must already be familiar with Android Studio. As you can see, when it does the Gradle syncing, it triggers a error right away. Basically, what it says is our modifier is not there. It doesn't exist. So it gives us an error. What you do is you go to the assets folder in your project. This might be a little small for you to see, but if you are an Android developer, you must already be very familiar with the setup. So now let's go find the 2 files we just downloaded from the Colab. I have it downloaded in my download folder. Remember labels.txt and model.tflite files. What you do is you just directly drag them into the asset folder. I will ask you whether to move the files there. You can click OK. I'll cancel adding it to the Git repository. So right now, this is the way to do it. In the future, we'll have better ways of importing the model files. The new feature will be launched pretty soon. So once that step is done, we basically are finished with step number 4. So now we can move on to step number 5. Actually, we already did the very first part of step number 5, which is moving the model file and the label file into the assets folder. So next thing we need to do is just to import the TF-Lite and TF-Lite support library into our app. So if you are a Android developer, then you must already be familiar with build.gradle. So in this case, as you can see, there's a to-do here. For this part, I'm just going to copy this file, the code from our Colab, because I don't want to type all this. And then it will introduce all the necessary dependencies. And then there's one more thing we need to do, which is we need to add we need to tell Android Studio not to compress our model file. Otherwise, the model file will not work. So what I do is options. Yeah. So basically, just add this ATP options, and then it will Gradle will not compress the TF-Lite file. So now we can do a sync again, just to make sure everything works. So this is in step number 5 in our code lab. So Gradle is taking his time. In the meanwhile, we'll move on to step number 6. So in step number 6, basically we are going to work in a Java file. If you go to your okay, so finally Gradle is finished. So we did not have any error or anything like that. So if you go to your Android Studio and then find the classifier float mobile net .java file, again, this is in step number 6. We're going to finish a few to-dos here to move forward. First, we need to tell our app. As you can see, there's already a bunch of code in the app. So what we are going to do is just to finish all the to-dos in the project. First thing you need to do is to tell the app that which model you're going to use in our app. So in this case, I'm just going to tell our app that we're going to use model.tflite. So this is the file we just downloaded from the code lab. And then we need to tell the app where to get the label files. Okay, so that's the first to do, which is pretty straightforward. And then the next thing we need to do is to go to classifier.java file. So there's a bunch of to-dos here as well. The first thing you need to do is to define a TF-Lite interpreter. So what the interpreter does is, as we train the model, we download the model file, and then we put the file into Android Studio. We need something to execute the model file, which is exactly what the interpreter does. So to add the interpreter, it's pretty straightforward. You just define declare a interpreter, and then you can we need to actually create an instance for the interpreter. So you can we need to go to the still we're working in classifier.java file. There's another to do, which is create a TF-Lite interpreter instance. So in this file, what we're going to do is just to actually create a interpreter instance with TF-Lite model and TF-Lite options. So basically, TF-Lite model is defined right above. It loads the actual model file we downloaded, and then TF-Lite options allows you to customize the way you want to run the interpreter. In our case, we define, the number of threads to use. If we have time, we can also talk about the GPU. This is also the way to specify of running your model using GPU instead of CPU on your phone. So now we have our interpreter instance defined. We need to do one more thing, which is once we are done with the interpreter, we need to close it. This is generally a good practice. It's not we recommend doing it. So the way you do it, you just do close the interpreter and then use null, change the TF9 instance to null. And then that's it. This is step number 6. We are already finished, declaring the interpreter, and then we can close it after we are done with it. And then that's step number 6. Now, step number 7, which is the actual meat of this whole collab, it allows you to run the TensorFlow Lite model. Basically, we will continue to work in classifier.java file. We need to find the other to-do, which is to define a image processor. Let me find that right here. Okay, so what this does is basically when our app will use the camera to capture an image, and we'll do some pre-processing for the image file before we feed the image into our machine learning model. So this is a very common practice because generally a lot of inputs needs to be pre-processed. You don't want to work with the raw inputs. So if you have worked with image files before, it's actually not that easy. To simplify users' workflow, we have created something called the TF Lite support library, which provides basic functionalities for you to manipulate different images. So the way you do it is you first create an image processor, and then you can add different operations to that image processor, and then what does the right job for you. So we're going to show a few processing operations. First thing is we are going to use resize with crop or pad op. So what this does is either cropping or padding the raw image. It's just as easy as adding a resize with crop or pad op. And then the second thing is we are going to do a resize op. So in this case, resizing means stretching or downsizing. We have two methods of doing that. One is nearest neighbor, the other one is bilinear. And then a third thing we need to do is to rotate the image. Rotate 90 degrees. And then last thing is we want to normalize the input image. And then we can finish building the image processor. So we already have this built. Okay. So as you can see, we to pre-process the image, we first did resize with crop or pad, and then we do resize, and then we do rotate, and we normalize the input image, which is basically changing the image to a range of 0 to 1. So that's the image pre-processing part. And then the next thing we do is actually running the interpreter, because we already have the interpreter defined. We already pre-processed the images. Now we're ready to actually run it. So let's find the to-do that actually allows you to run the interpreter. It's actually pretty easy. You just use TF Lite interpreter, and then you call the method run. You will take the first parameter, which is the byte buffer generated from an image buffer. And then we also need to specify the output, which is the label probability. Rewind. So this one line basically just runs the interpreter for you. You give it the input the buffer, and then it will fill up the output buffer for you. And then one final thing we need to do is to get the output, right? So in terms of this particular model, what are the outputs is an array of probabilities of our input image belonging to one of the 5 categories of flowers. So in this case, we need to get out of the mapping of label and the associated probabilities. So in our case, we'll just do we'll first define the label probability, and then we can use a convenient utility called tensor label. And then we can associate the label with the probability processor. And then we can process the output buffer. Yeah, my font size is maybe is a little bit too large, so you cannot see the whole thing. But you can refer back to the code lab that has the complete code. And then that's it. That's the final step for our app. So hopefully you are following what I'm doing, and now we can start running the app. Now we are into step number 8. So if you have a physical Android phone, you can directly run it on your phone. In my case, I'm going to use Android emulator. It will okay. So now it's up. I have an image of the sunflower. Let me show. It's a little sluggish. Okay. Okay, so basically, if I have the my phone to my camera, then it will start to recognize it's a sunflower. My emulator is a bit of a slow today, but okay, it's coming back. Let me make it bigger. It's really hard to operate this phone. Yeah, so because there's a lot of background images, so the accuracy is not that high. But if you are using a physical device, you can probably do a Google search and then find a few flower like sunflower, daisy, or those kind of flower images, and then it will correctly recognize the flower images. So that's pretty much it for integrating. By the way, if you are using emulator, a couple of things you need to do. One is turn on the Android Studio, the Android emulator camera. In which case, you need to change the setting in the virtual device manager. You should go to your image and then go to the advanced setting, and then change the front camera to your webcam, and then it will take the input to the emulator. So that's step number 8. So I think due to in the interest of time, I'll skip step number 9, which is to use GPU to run our machine learning model. Basically, your phone these days, a lot of mid to high-end phones come with more just CPU. It has GPU, Some phones even have, DSP or NPUs. So those are the specialized accelerators that allows you to run machine learning model much faster than CPU. So in our case, TensorFlow Lite does support GPU. It uses a mechanism called delegate. If you're interested, go through the step number 9 in our collab. It's actually pretty easy to use that. But in this case, I will not do that part in the interest of time. So if you have followed what I just did, let me just quickly summarize what we actually did. We used the Colab model maker to train our machine learning models, and then which is really straightforward. It's like 5 or 6 different steps, and then we downloaded the files from the Colab, and then we integrated the downloaded files into our Android app. In our Android app, we used the TensorFlow Lite interpreter to run the model and then get the image flower recognition results out of the machine learning model. And then we use, in my case, I used the Android emulator to run the actual app. So hopefully that gives you a taste of what a end-to-end mobile machine learning projects looks like, and then hopefully inspires you to do some more work in this area.